It works on my machine. Have you ever heard those words? It works on my computer over here, but not on your computer over there. And the reason will turn out to be some subtle difference in the way we've got our machines set up. And I don't know what it is, but apparently it's important. So we have to dig down and find out. And eventually this is going to end with someone updating the README to say, you must have OpenSSL version 3.2 installed first. And no one actually ends up reading that README, so the problem keeps coming up. But at least you can say it's there in the docs. To be fair, that's probably the worst case. Things have got better since those dark days, because generally now we solve the different environment problem by shipping the entire operating system to everyone that needs to use it, as defined by a Docker file. Docker has become the tool of choice for reproducible environments, and it's been really great. In practice, it has worked out terrifically well. I personally think it works a bit better in production than in development. For production, it's generally quite reasonable to ship a few different virtual machines. It's never sat entirely comfortably with me in dev, because if I need access to 3 or 4 quite different programs, I shouldn't really have to run 3 or 4 different virtual operating systems in Docker Compose. That always seemed weird to me. And generally, I don't actually. There's a different approach I use that isn't Docker, but that solves the reproducible environment problem and ends up feeling a lot more like you've just got everything installed locally. So this week, I'm joined by Julian Arni, and we're going to talk about Nix, which started life as a PhD thesis in how you make builds reliable, and has grown into this tool that can define and build just about any programming environment you need. I use it basically every day on every project I have. And I find it's particularly good if you end up jumping between a few different projects that all need different environments. So this week, Julian's going to unpack what Nix is, how it works, and why you might want to add it to your toolbox. Or actually, more specifically, why you might want Nix to become the box you hold your tools in. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Julian Arni. I'm joined today by Julian Arni. Julian, how are you doing out there?
I'm doing great. Thanks for asking.
Very excited to be here. You're over in Basel. In Germany,
Basel.
Right? Basel. It's pronounced Basel.
Basel. It's in Switzerland, on the border, exactly on the border with France and Switzerland and Germany. So if I go for a run, it doesn't have to be a long run. It can be a 5K run. I can cross into the 3 different countries, right? Past the 3 different
that's
countries.
Cool. Do you have to take your passport?
Officially, yes, but I don't think anyone does, and I never have.
The freedom of movement that I've lost, but let's not get into Brexit. That's a different podcast. So you're here to talk about building things, DevOps, a topic sometimes I shy away from because I've found it so painful in the past.
Understandably.
Yeah, but there's... So maybe I should tell you my background just for a change. Mm-hmm. I worked at a company that used Nix many years ago as a contractor, and they basically paid me to learn Nix because I had to, right? So I've always felt that I've come at Nix from a strange angle. The initial hump being paid rather than voluntary.
Yeah.
So
yeah.
And mandatory. That was the other thing. I never had the here's why it's good. I just got told by diktat I should use it. So I'm hoping you can start by filling in the why is Nix good question.
Exactly, so that I can convince all the other people who are not being forced and paid to do it to take a look at it. Yeah. I think, the sort of space that it's operating in is the space of sort of reproducibility, right? Making sure that works on my computer, works on yours as well. And that's a space that we as developers are very familiar with, and we have our techniques to solve it, right? Like I think Docker is by far the most popular one. Yeah. But Nix is coming at the same problem from a very different angle, and as a consequence, it doesn't have a lot of the problems that Docker has, which is actually, to some extent, most obviously, that it's not that reproducible. If you want to, run the same Docker file twice and it's not cached, you could get very different results. But then additionally, a number of other things, it's hard to sort of abstract over them. It's hard to connect multiple Docker files together, combine them. You end up spending so much time when you have Docker images sort of poking holes at the isolation so that they can talk to one another. It's very different than the way in which you program locally, right? Like usually, if you think about the Unix philosophy, you have a pipe operator between two different programs, and that's how you compose them. Whereas if you have Docker images, you suddenly have to have HTTP ports and make them into web applications or whatever mechanism it is. It's very different than how you traditionally locally think of programs. And so there are all these costs that are associated with the Docker model that aren't there in Nix. And additionally, there are lots of things that it enables that you wouldn't even think are possible, right? So I think some of the things that are quite phenomenal is just the sort of incredibly sophisticated build caching that it has, and with once you sort of start using Nix OS, the sort of, which hopefully we'll have time to get into.
Definitely.
It gets even more exciting, I think, right? Like you can sort of see rollbacks, sort of get your machine to any state very precisely, and know exactly what state that is. Be able to diff machines in incredible detail with your usual sort of version control tools.
Because definitely Docker files sometimes feel like a bit of a black hole.
Yeah, in some sense, it's a very nice interface. The Docker file, it's a very familiar interface on the one hand, right? Like you write essentially a bash script. It's a little bit different than a bash script, but you write a bash script, and then it's like it's cached and kind of isolated, and that sort of initial experience is very, very nice. But then as you start progressing beyond that first, those first 5 minutes, it becomes cumbersome in a variety of different ways.
Yeah, I think one of my least favorite is that if you add a command to a Docker file, everything's groovy. If you want to go back and change an earlier one, suddenly you're in a real build time problem, right?
Yeah, that linearity is very strange, right? Like in some sense, the caching is linear, right? And so you have to think very carefully about the order in which you do things. And as you said, if you change something early on, it might have downstream consequences because, maybe you're downloading something from the internet and the cached version that you had so far changed. And now everything else is going to be different as well, right? So you're kind of in this.
Yeah. I think we should build up the picture of how this all works, and then we can really talk about it. So what's it doing that Docker isn't? What's the mental model for Nix?
Yeah. Docker, in some sense, is taking a snapshot of the file system at a moment in time, right? You just take a picture of whatever it is, whatever state it is that you got into after running a few commands, and you save that. And there's a story about layered file system and whatnot, but that's essentially the approach, right?
Yeah, snapshot the whole OS, call that a base, and then keep adding snapshot changes on top.
Yes, exactly. Yeah. Nix is much closer to a different technique that is also very familiar, which is the package lock files, right? So we what I mean by this is, you have language specific tooling such as Cargo or NPM that nowadays, or Python pip or the various other Python tools that take your project and maybe some version bounds of dependencies that you specified, and talk to the internet, find out what versions are available that match what you requested, pick those versions, and then output that into a lock file, what versions it's picked. Now,
to pin the specific binary or the specific source code.
Exactly. Yeah. So you can think of this as what's happening is, after you've pinned this, the process of dependency resolution with that lock file is deterministic, meaning it'll always be the same because you pinned it, very, very precisely. Not just a version number, because sometimes you can change the meaning of a version number, but also the hash very often, right? Like it's the specific source hash. So then after that, if anyone else tries installing it, they'll get exactly the same version.
Yeah, because it's usually it's often pinned off Git, which means it's cryptographically secure all the way back through the source code. So you get byte for byte exactly the same.
Exactly the same.
Yeah.
And so this is kind of, that lock file is, if you take that lock file and extend it in two different ways, you get something that's essentially the Nix idea, right? The first one is that you extend it to everything, right? Like it's not just for a specific language dependencies, right? Like it's not just for your Go dependencies or just for your NPM dependencies. It's for everything. It's for all your different language dependencies, all parts of your projects, your system libraries, your various, like maybe images or whatever you're downloading from the internet. Everything that is outside of this isolated sandbox that you need to fetch ahead of time, including, for instance, the UTC time or all of those things. Everything that could matter to your build, you're pinning.
Because if like you and I build the same Rust project, because of the lock file, we get exactly the same cargo dependencies. We might have a different version of libopenssl.
Exactly, or zlib, or whatever else it is, right? Or a runtime binary that you use, right? That you're expecting to be there. That's not a Rust project, right? Maybe you use core utils or something like that, right? And often with languages, you even sort of you pin all the versions down, but you don't pin exactly the compiler version or something like that, right? Like somehow the domain in which these lock files operate is just the library versions.
Someone says it doesn't build on my machine, and you say, well, which OS are you on? Which version of Rust have you got? Yeah, and then you start wading through those reads.
And that what you mentioned is a really good reminder, right? Like even another thing that's pinned down is the OS version, or whether your architecture is 64 bits or 32 bits, or whether it's an Intel or ARM Mac or Linux, right? All of those things are pinned down, so that like really conceptually, if you build it twice, even without caching, you'll get exactly the same thing. Now I say conceptually because there are small exceptions that maybe we can get into at some point, but that's number one, right? You start with lock files, but you're going to pin down everything, right? And then the other thing that I think is a very, very big deal is once you've done this, you can use when you build your project, right? So you pin down not just the Rust dependencies, not just the Go dependencies. Maybe you have a multi-language project in a monorepo that involves various different languages. You pin all of this down, and you ended up with a binary. The cool thing here is that you can give it. Usually, you might end up with out or some binary version like that, or my project, and that's the name of the binary. But what you could also do is name that binary the hash of all of those inputs, your lock file plus your source code, right? The lock file that includes everything else that's not your source code and your source code.
Right, yeah. So you get a cryptographic signature of that specific binary.
Yes. Yeah. And so now you have a very good name to refer to that binary, and you can have various different versions of the binary coexist, right? So you build that, for instance, and then you check out a different branch and you build it. And now you'll have two different binaries with two different names, and they won't overwrite one another. Usually when you do a cargo build or NPM build or whatever it is, you will overwrite whatever binary you had previously built because there's a specific name there that keeps changing. And that has... if anyone was using that binary, now they'll have a different version, right? Whereas with Nix, you tend to use these names, and there's a lot of infrastructure around making it easier to refer to software without having to explicitly mention these hashes. But that's, you're going to name everything this way. And so various different versions of binaries of artifacts can coexist without a problem, right? You do this for directories as well. So when you do a system upgrade in Debian or whatever operating system it is that you have, you'll overwrite the version of Python that's in user bin or wherever it is.
Your bin sometimes with immediate regret.
Exactly.
You need to go back and use it.
Yeah. Whereas here, my project can say, oh, I want exactly this version of Python that's known by this hash. And then it'll never, as long as someone's using that version, it'll never get deleted, but you can upgrade your OS and it'll just install a different version of Python alongside it with a different hash name. Right?
Yeah. Do you know, I've used this to great advantage specifically when I've been contracting for different clients. And you've got like one client that's on this version of the JVM and another that's on that version. And you want, and like maybe they have different underlying C libraries, and you want both versions to coexist on your laptop so you can work for both clients without going insane. It becomes trivial, right?
Yeah. And this is where one of the superpowers of Nix that it's quite famous for, and rightly so, comes from, right? This notion of dev shells. We have a little bit of this. We have a little bit of this with virtual envs and things like that allow you to sort of enter in very limited ways, enter a specific Python environment with a particular version of Python installed and whatnot. But Nix again does this for everything, right? So you can now create development shells that are that have all of your all the versions that you want installed. And what that does is it just symlinks into your path the specific Python version. They have a hash Python /hash or whatever -hash, and you just symlink that as Python into your dev environment when you enter it, and then unsymlink that or remove it from your path. But you're never deleting anything or overwriting it. You're just sort of entering an environment that exposes a specific version of each of those things under the path, so that then you can develop with the version of Python that you want, with a version of Cargo and Rust C or whatever it is that you want. And this, this one of the great joys is, you can create a project at work or in your open source project, make a dev shell, specify the details of a dev shell for it in Nix, and people will come along instead of needing to sort of read through a README and carefully try to emulate everything, can just do a Nix develop and enter that dev shell with all the tools that they need to build and test. And I have thought in the past, when you've got like installation instructions that are more than just build the language project, you've also got to install these dependencies first. That's where like that should have been Nix or something very similar, right? Also because it's it's not just sometimes hard to follow those instructions, but it's also sometimes, I think very often, hard to write them correctly, right? Because you don't know, the dependencies of your project are very often implicit, right? Like you don't know whether your project is, or you've forgotten whether you're using zlib or whether a particular version of bash has to be installed versus another because, you have some particular syntax that's only available in bash 4 or up or whatever it is, right?
This is another thing you get with Nix, which is the isolation, which gives you an environment that doesn't include the things you're used to having on your laptop.
Yeah, exactly. So that you know exactly what it is that matters, right? Like it's being able to empty your environment is really important to understanding what it is that you actually need, right?
So I'm sure I've hit that with something like ImageMagick. It's like, oh yeah, you also need to install ImageMagick. I hadn't put that in the instructions because I've always got it installed.
Yeah, exactly.
And I hadn't thought about it. Yeah. Okay, so I think there's if someone has bought into the argument that like a cargo.lock file or a package lock file or something like that is a good idea, we could go deeper and apply that to all the surrounding stuff for the language. The question is how? How does Nix do it, and what will it cost me to start using it?
Yeah. Fundamentally, what the experience of, I think the fundamental sort of unit of Nix is a build, a derivation. I won't go into details about that terminology yet, but fundamentally, a recipe for how to build a project is and then actually building it is what Nix cares about. And the way in which it does that is by isolating the build environment and sandboxing it so that you don't have anything that you didn't specify, right? So, and then there you specify usually something like a bash, and this way it's somewhat similar to Docker. You specify a little script that says this is how you will build my project. Maybe it's cd into this directory and do a cargo build or a make or whatever it is, right?
Yeah.
And there's a little recipe there, but it's run in without network access. Without access to the rest of the file system that's not your repository or main directory.
So it's not accidentally picking up hidden inputs that you hadn't thought about.
Exactly.
Yeah.
You won't have a version of Python at all unless you say, I want a version of Python, and then you have to say what version this is, right?
Yeah.
And so then you have this recipe that can be run by someone else that will Nix will again do exactly the same thing. Isolate, create an isolated sandbox, and then run this recipe, right? Making sure that any dependencies that you specified are in fact available to it, right? So if you said I want this version of Python and this version of Cargo, then those things will be available, but nothing else will. That's how it kind of operates, but there's also this sort of surface level language, in the same way that with the Dockerfile, there's this semi-bash syntax. In Nix, there's also Nix the language. That's the equivalent, right? So it's you write these little data structures that explain your build recipe, right? And most obviously, what that contains is the script that will do the building.
Yep.
And then also the dependencies, right? So you specify packages.bash or whatever. And that will add those things to your dependencies.
So one thing I've always wondered and never actually looked into, maybe you know the answer to this, but if I want to build my Rust project, right, I will specify one of my dependencies is Rust the language.
Yeah.
So Nix will go off to the recipe to build Rust the language, and it will find that one of the dependencies is GCC, let's say.
Yeah.
Goes off for the recipe for GCC. It finds one of the dependencies to that is a specific kernel. How far back does it go? If it's turtles all the way down, what's the base turtle of this build?
There's work to sort of have a minimal sort of minimal base, so that usually with these things, it's a little bit like these compiler versions, right? Like with compilers. Very often, compilers are written in the language that they compile.
Yeah,
I don't know. An example is, I think, Rust, but also Haskell, right? Like, and so how do you get to produce the current compiler version? Well, you get an earlier one and you use it to compile the source code, right? And this is a little bit annoying for reproducibility and for making sure. So there's work to make the space a little bit simpler, but in practical terms, it won't go that far down, right? Because when you need a dependency, such as Rust, someone in the Nix world had to build that Rust compiler. But there's a NixOS organization that for nearly 100,000 different packages does the builds already. And this gets into a different thing that is very, very nice about Rust, about Nix, which is binary substitution, right? So if you're asking for a thing by this very specific name, right? If you're asking for cargo with a specific hash, because everything is specified in that hash already, everything that could possibly matter is in that hash. If anyone that you trust has already built that, you can sort of just ask the internet, you have to be careful that you trust these people, but you can ask the internet, has anyone built this? And if they say yes, you can just use that instead, right? So you won't be building, when you build a cargo project, you won't be building all these things. You'll be downloading a binary that is the already built.
Because Nix can calculate that it must have come from the same tree of the exact same tree of dependencies.
Exactly.
In order to have the same output
hash name. Yeah.
Yeah, same hash.
Yeah.
So it's
that's
just
really
pulling
cool.
the Git trick, isn't it? It's the same trick that Git uses.
Yeah, yeah.
Hash it, build
yeah.
a tree of hashes.
Yeah, yeah.
Yeah.
That's right. Hashes are, in some sense, the deeper lesson is just that hashes are really good names for things.
Yeah. Content addressable file systems. We have to get that terminology in.
Yeah.
Perhaps that's the solution to one of the two hard problems in programming, right? Naming things.
Just
name
exactly.
it by the hash.
Yeah, exactly. Which, to be fair, also, Docker to some extent does as well, right? But it hashes the output, the result of what it built, rather than the inputs that went into it. Right?
Yes. Yeah. That makes me just want to say, I think this is true. You can confirm for me. You can also use Nix to build Docker images, but with better hashing, right?
With better hashing.
Like you get a Nix quality input hash for your Docker output.
That's right. There's a project that's quite widely used, and in Nix packages itself, that's a way of building a layered Docker image where the layers are quite minimal. So it's easy to if you think about the way Nix operates, right, with these hashes, in some sense, it's solving the problem that Docker has that we mentioned before with linearity, right? Like with Docker, it's like if you change something earlier on, you don't know how that's going to impact the rest of the thing. So you have to go back and start building from that line that you changed, essentially. But with Nix, we know that when you build a dependency, when you add something to the file system, it'll only influence. Nothing else will influence it, right? Like that when you build a Python with a particular hash version, it'll be exactly that. So you can really sort of make very, very fine-grained layers, and you can also rearrange them somewhat more safely. And that is something that people use a lot, right?
I've definitely found the experience of refactoring and rebuilding a Nix file to be much faster. Than that of a Docker file.
Yeah.
And these things start to matter once it becomes large enough that it is something you want to maintain, right?
Yeah. I think that's true. Right? The other thing that's a bit harder to sort of give a sense for, and I recommend people just try out, is that Nix has these ability to create what I always say is, you mentioned at the beginning of this podcast, like DevOps is something that I often shy away from, and I think that's a totally comprehensible perspective, because when we live within a programming language, there's very clear semantics, and we kind of know how everything works, and we can kind of abstract things in exactly the right way and capture them, and really find nice ways of expressing things, and the language doesn't work against us, and there's so many different languages to choose from that really almost capture the language of thought itself. And then you have these libraries that abstract over bits of functionality, and you can combine the libraries and whatnot. But then when it comes to infrastructure, to DevOps, right, like it really is like gnarly and feels like duct tape all over.
It certainly can, yeah.
Whereas Nix goes much further in the direction of making DevOps feel like programming again, right? Like you can abstract over these. If you have multiple different servers talking to one another, not only can you describe builds, but you can describe entire servers, and not only entire servers, but entire sets of servers, right? And so you can sort of really abstract over the idea of, for instance, having all of your infrastructure servers talk to a Grafana Prometheus, export things to Grafana and Prometheus, and that just becomes a flag, right? Like something that you can just enable in all of your servers.
Like you can start to, because the description language, the equivalent of the Dockerfile, is a lot more like a programming language.
Yes.
You can start supplying arguments to your builds.
Exactly. Yeah. Supplying arguments and writing functions that abstract over. Exactly.
Yeah. I'm defining a build that builds several different versions because it's effectively just a for loop or a map.
Yeah.
Over build files. Yeah. This sort of gets us into the space of, because we talked about Nix, there are three parts to Nix, possibly more.
Yeah.
Nix, the tool for building stuff with this dependency tree we've talked about. Nix, the language for specifying those recipes. You've hinted at Nix OS. Do we have to buy into a whole other OS?
We do not have to buy into a whole other OS. This is entirely optional. Entirely optional. People. I, for instance, run Nix OS, and I think a lot of people who are given the chance and the opportunity to spend time learning Nix often will, because there's a lot of joy to begin from it. But it's completely optional.
So, what does it get you? Why would you make that option?
Yeah. I think, when you think about what getting a server to be ready to do the functionality that you wanted to do, maybe run your web server or whatever it is, your website. There's usually like a lot of very sort of imperative instructions, such as sudo apt get this and sudo apt get that, and then move this file here and whatnot, right? And as we generally know, that this can be really, really dangerous as well, because it's a very stateful system. If someone logs in because they notice that there's a problem, maybe with a missing version or whatever, a missing binary, maybe they do a sudo apt get there while SSH'd in, and you never know that was part of what makes this machine tick, what makes it go in the right way. And that's a big problem, because if you need to migrate it somewhere else, or if you need to, redundancy or whatever, you won't have captured that, and you'll forget about it the next time around. Nix, as we've been talking about, it's very much about sort of really isolating your system from all of these stateful interactions, right? You really have a build recipe that you specify once declaratively, and that's it, right? Like the state that happens afterwards, that accumulates, the cruft that accumulates in your own computer, for instance, is ignored during a Nix build, for instance, right? Like it's all about this isolation that makes the recipe capture everything there is about a build. And it's the same with the OS, right? So you can specify an entire OS that tells you exactly which files you need to have installed, in which locations, which systemd services. It's a Linux-based distribution. Which systemd services are there, and then you have all of this information, right? So you can really, if you want to spin up a new server, you can very easily do that by just reusing this recipe.
Yeah, it's part of this, I think, is again that moving things from a README with a list of commands to type at the command line into an actual programming language where it's repeatable, right? Yeah,
absolutely.
Yeah, if we're describing it in prose repeatedly across the whole industry, we ought to be describing it in a programming language.
Yeah, absolutely. And there is people say, like, if you're doing the same action multiple times, often a technique that I heard that I like a lot is write a little bash script that at first, just prints out the different sections, the steps of the README, and you say, like, have you done this? Yes or no. But then you can slowly start abstracting that, right? Like if there's a step that you can do automatically, you can change that instruction line for, instead of just echoing the instruction, you actually do it. So this is this doesn't solve the problem of reproducibility, but it does automate something, right? This shell-based system. Whereas Nix really solves the problem of reproducibility as well, right? So that you don't need the READMEs anymore, right? You just have one command that does everything for you.
Yeah. And it also takes care of some of the sequencing, right? If it doesn't matter which order you run the commands in, then you don't need to worry about that. And if it does, you can specify it as an actual sequence dependency, right?
Right. Yeah. And you can build all these dependencies that we were talking about, right? Like we can build them in parallel, right? Let's say that you need both a Python version and a Rust version. Usually you won't build that locally yourself because, as I mentioned, you'll be using a cache that's already built it for you. But let's say that for some reason, you have a patch to Python and you want to build it yourself, and the same for the Rust compiler. With Nix, because these are very isolated, you can safely run these in parallel, right? And so this sequentializing, this annoying sequentializing of Docker is something that happens a lot less. Right?
Yeah, and that specific example I've seen play out two ways. The first is that you can build each language on different threads.
Yeah.
And the second is, like, if you wanted to do that with Docker, would you get a Python base image and add in Rust? Or would you get a Rust base image and install Python?
Yeah.
It's probably just a question of which one's harder to install first. And that's not the best answer I can imagine.
Yeah.
Right?
Yeah. It's just the wrong structure in some sense, right? Like a list.
Yeah. Append only is probably not the right data structure for build tools.
Yeah.
Okay, so from there, I think one thing we haven't talked about is time, the effect of time on this. Because I have found Nix very interesting when I go back to old projects. It's like especially when I come back to the time when I was doing a lot of contracting for different companies.
Yeah.
And I would build a project and I accumulate this cruft from old projects and things I had to install for old projects, run out of disk space, clear it up, go back to the other client, and then find I've got to reinstall all the old dependencies for the previous project.
Which might not even be possible or easy, right, to find those dependencies anymore.
Yeah. And then you get into now I've got the latest version instead of the version I installed when I was working there 6 months ago.
Yeah,
it's one of those nice advantages. Like, once you've actually specified all this in code, either it's in the cache or you can go and grab it from a remote cache and rebuild it exactly as it was, right?
Yeah. It feels like one thing people say a lot is that it's a little bit or to a lot more upfront cost, because let's say that you're building a project, you already have a version of Python that you already have installed if you're a Python programmer, and it's very easy to just be like, Python so and so, like put in a README Python this file is all you need to do. Because for you, it's no extra work, right? Like, you already have the Python version installed. It seems like it's no extra work. You might maybe even have the dependencies installed somehow globally that he didn't notice. Whereas Nix forces you to be upfront about that cost, right? Like, you really have to think about what Python version it is that you're doing, and you have to specify those things. But once you've paid that cost up front, it continues. It's a gift that keeps on giving for years in the future, as you mentioned, right? Because if you come back to a project from 4 years ago or 5 years ago, it still works.
Yes. You've got a good reason to believe that it will still be able to build that entire source tree again. And build it.
Yeah.
Some of it may have aged out of the remote cache, but it's still possible.
Yeah. And the cache has so far the policy with the cache, with the sort of Nix OS, the Nix org cache, right, the sort of official cache, has been to keep things indefinitely. That will probably change, but it's still the case now, even after a number of years, and that's really exciting, right? Like, not only can you build it again, but you can build it without doing a lot of rebuilds, right?
I suppose that must play into the amount of disk space it uses. Because if you wanted to store the binary for every Docker image, that would be a different thing. Because that's going to not just have Python 3.7.6, but it's going to have Python 3.7.6 for every different Docker file that uses it, right?
Yeah. That's so. The disk space issue is a serious one, both with Nix and with Docker, and it might be more serious with Nix than with Docker, right? Like,
okay, tell me.
As you mentioned, with Docker, you have if you in one Docker file you have a Python version installed, and in another Docker file you have a different Python version installed, and they don't share layers because they're different images. or you did something earlier on that's different, then you'll have that Python version, that supposedly exactly the same Python version installed twice. That's the thing that Nix solves. If you have the same Python version that you're using in two different projects, it will be stored in your Nix store only once. So on the one hand, there's an advantage here. But because every time you do a build with Nix, and if you're working with Nix, this can happen a lot. Whatever you change, an environment variable here or something else there, or a GCC version, all of these things will change the hash. Anything that could possibly affect your project will change its name, which in turn means that it will be stored twice. So let's say you're building a Rust project and you have you want to add a comment in your source code, and you built it once with Nix and then again with Nix. Because the source code is now different, the hash of the resulting artifact, the resulting binary, will also be different, which means that they'll be stored in twice over, with some exceptions and small optimizations here and there. But essentially, that's the idea, right? So you end up using
I
a lot
think
of
I can
disk space.
accept that. Yeah, I think I can accept that if I've changed the source code to my project, I've got a different output. But there's an almost philosophical question here. If you have a version Python 3.7.6 built with this version of C, and Python 3.7.6 version built with a different version of C, are they the same Python 3.7.6?
No, Nix say not.
Nix says no.
Yes. And, that's philosophically, I think that's the principled answer, right? Because in fact, it could be that there's a bug in GCC or whatever C compiler you're using.
Slightly different behavior, yeah.
Yeah, exactly.
Yeah. I think the realistic answer is yes, they're the same until you're the poor Muppet that's trying to debug the difference.
Exactly. Yeah.
You don't want to be that guy.
Yeah, that's right.
So this raises one question I wanted to get in from that is, because I don't know what the current state of this is. I remember 5-6 years ago with Nix there being a slight problem in that it worked brilliantly on Nix OS and Linux. It didn't work as well on Macs because the funding for build machines, because it's an open source project, right? And you need a whole farm of Macs to build the caches up.
Yeah.
What's the state? But now I should say for the record, now that's much better and it works perfectly for me on OS X. What's the state of Nix on Windows?
I think there's very, to be honest, I don't have a very good sense. The truth is, neither I nor anyone I know develop on Windows.
We'll have to leave that for the comments section then.
Yes, there is, I think, efforts to support Windows, and there's always Windows subsystem for Linux and whatnot that do allow you to use Nix via WSL. But I don't know what the experience is like, right? I think that's really a very important question. Is what does it feel like when you actually try using it? And I have no idea.
Yeah, actually, so we'll have to find another way to get that information. But that does lead into something I've experienced using Nix. It feels a lot more like I'm running software on my computer as opposed to I'm running a virtual machine on my computer.
Yeah, that's right. I mentioned a lot, the sandboxing, right? And that's in the build process. You do want to sandbox things and kind of isolate them from the rest of your computer. But once you have that binary, you can now safely use it as if it were any other binary in your computer. Whereas with Docker, usually, you build something and then you continue running it. If you have a Python version or whatever it is with certain dependencies, and it's still running inside the Docker container, right?
Yeah.
It's not just not just getting the Python version. So even after that, you have to continue using Docker. And then when you want something, when you want to communicate with that, it's always a bit more of a hassle, or a lot more of a hassle. Whereas with Nix, you really can just pipe things, call them as in a bash script or whatever it is, right? And
yeah. You don't end up with Nix doesn't have an equivalent of Docker Compose, right?
no.
And maybe I should get you to explain why it doesn't need one.
Fundamentally, it really is because, in some sense, these again, when you're thinking about infrastructure, when you're thinking of large scale infrastructure and deploying it to multiple servers, then of course there's a question of like how do you coordinate, how do you organize, capture that infrastructure declaratively, right? And that's one thing that people use Docker Compose for. But they also use it locally, right? And that part isn't necessary in Nix because you don't need to be spinning up several Docker images to run specific versions, to run your backend, run your database, or whatever it is, right? You can just run them in the same ambient environment.
You're running Postgres as though it were a local binary rather than a separate virtual machine that connects to your source code's virtual machine. And
yeah.
So, I mean, I was sold into Nix, but I've been a convert for years, and I use it for all my projects. But you have gone further. You've been sold into it to the extent that you want to build a whole service around Nix.
That's right. Yeah.
So what's missing in the world of Nix that you felt the urge to build?
I think actually quite a lot. In some senses, what's missing in Nix, to make the experience of Nix users better. But in some sense, it's also, like, it kind of feels like when I think about Nix, right? Like it's already a relatively old project, but when I think about Nix, the adoption it's not the industry standard yet in the way that Docker is.
No.
And it feels a bit like discovering Nix feels a bit like, discovering a garden where there hasn't been anyone, like full of apple trees. There hasn't been anyone who saw this, and this is not like it's like somewhere off in the corner and not the main thoroughfare. So when you go there, all the trees are really laden with fruit, and you can really pluck the low hanging fruits without any effort. Right? There's so many benefits that people haven't yet explored and investigated to their full extent in that sort of paradigm shift. And that's one of the things that really excites me, right? Like I think an example, so two big examples is, how much better CI can be if we base it on Nix instead of anything else. How much faster, how much easier, how much more reliable. But then another is, how much better our deployment infrastructure can be, right? So that we can really abstract away ideas such as like having three Postgres servers with redundancy and failover or whatnot. How we can get zero downtime deployments really easily, atomic upgrades, so that different web servers don't need to worry about staying backwards compatible or forwards compatibility, which is a huge deal when developing. All of these things, like, once you sort of start thinking in terms of the basic conceptual infrastructure of Nix, all of these things become possible, right? So partly it's solving an existing problem for Nix users, namely, the situation is a little bit like Git before GitHub, right? Like GitHub came along and made Git much more accessible, right? Previously, you had to, you were a Linux kernel developer probably if you're using Git, and you had to sort of format patches and attach them to your mail client, and then also verify the signatures and use GPG and whatever it was. It was, it's a workflow that for a lot of people was actually quite enjoyable, but definitely not for everyone, right? Whereas GitHub comes along and makes this really clear that that version control is a really good idea and that Git is a good implementation of it, but then also makes this accessible to people who aren't developers, and they can use this interface and see their change directly in the UI, make changes. And I think like this is something that Nix still needs. It needs a company to or several companies, hopefully, to come along and say, hey, we can, all of the accidental complexity we can take care of, right? Like if you if you want to enable CI, it's just one button. If you want to deploy, 7 different servers in 2 different environments, that's also, like 2 or 3 lines of code. And that will really potentially even abstracting away some of the experience of using Nix itself, so that this becomes that, so that we can benefit from the conceptual advances that Nix brings without the admittedly quite high barrier to entry. Right?
Give me an example of how that works, because it's like I remember there being a project called NixOps, right?
Yeah.
Which was attempting to say we can describe infrastructure using this same language we're using to describe builds.
Yeah.
But that project, I think, died for lack of support. I don't think it's still going.
That's right. It's not fully dead, but it's nearly.
But are you taking up the mantle of that core idea, which is we shouldn't have a separate language for builds and a separate language for deployment infrastructure?
Somewhat. I think that idea has already pervaded some of the ways in which people use Nix, right? So Nix has this addenda, let's call it, called flakes, which is a sort of a standardized way of organizing your project, and that means Nix language allows you to build things, but you probably want to separate the packages from the tests and make clear to people what it is that those are, and have a standardized way of saying I want to run the Mac test because I'm on a Mac rather than the Linux Intel ones, and sort of specify again in a sort of like very simple key value way almost what the dev shells of this project are, right? So Flakes has become a somewhat controversial but also de facto standard for how you organize your projects.
Yeah, and you've raced past that one point. I'm going to emphasize it. It's very nice to have, as well as like a script that defines how to build it, also says these are the tools you'll want available in the shell when you're developing.
Yeah.
That's a really nice angle of that. Yeah. The dev shell, as you mentioned. Sorry, carry on.
Yeah. So there, I think the majority of new projects by far use this sort of use flakes, and they allow you to specify also NixOS machines, which, I mean, as we mentioned, you can have entire NixOS systems built on Nix, which you can run locally in VMs, or which you can deploy. And so what we do is say, okay, like, well, given that you probably are already writing all of these things, if you're Nix savvy, there are options if you're not Nix savvy, but if you've already written this, what we say is, okay, we'll just build all of these things without you having to specify any more details. We'll just build all your packages and checks on CI. And if you say, I want to deploy these 7 servers or these 5 servers, we'll also deploy those servers for you, right? So we're not coming up with a new idea about how to deploy and specify large-scale infrastructure in Nix, because this has already been, there are some already accepted practices in that regard. We're just making it automatic, right? So it's a platform as a service, right? Like you push to GitHub and we run all your tests and we deploy automatically. So kind of the ease that you might expect from Heroku or something like that, but with an entirely Nix-based system.
Is the trick here that a Dockerfile is more like a bash script than anything, right? And you can't really like build the syntax tree and do compile time analysis in the same way in a Dockerfile that you could on Nix, the language. And what you're doing is saying, well, we can peer into this language and peer into these specifications and figure out what they're trying to do. And use reuse that machine language for a different purpose, the purpose of deployment.
Absolutely. And it's beautiful. Like I really get a lot of joy from thinking through the various ways in which this is such a beautiful idea and concept, right? Like one of the things that's really great is you can actually see, because you can peer into the structure, as you say, you can say things like, oh, what is my network topology? Which machines are talking to which machines? Or what are the versions, let's say that we know about a CVE that just came out in Python affecting this version range. I can say, okay, which of my machines have this version of Python installed, right? Anywhere at all, right? So you can really peer into with remarkable detail, right, and into your entire infrastructure, and really start programming with it, right? Like coming up with questions to ask or ways of automating systems and whatnot that really work well.
We talk a lot about infrastructure as code. We don't then make the leap to say code as source of information we can automate further, right?
Yeah. There is absolutely. There's this nascent idea in things like Pulumi, for instance, right? Like let's use the data structures of a proper programming language, so that. But there are problems with using an existing language like that to do these things, right? Like, there isn't really clarity about these structures, and running the same script twice might result in different structures, and you never know. And so it feels, again, a bit ad hoc, even though it recognizes the importance of being able to manipulate your infrastructure as a data structure.
Yeah, because it does sort of push, if you want to really unlock that, it pushes you away from languages that are inherently imperative. You want to get more towards a language that's more like just a big data structure.
Right, yeah.
Which I guess is kind of a trick that Lisp figured out back in the 60s and we keep relearning, right?
Yeah, that's right, yeah.
Okay, so tell me, so your service for this is called Garnix, right?
Yes.
And I do want to know what state it's in, and because I'm always interested when programmers get so obsessed they become like builders of services.
Yeah.
What's that road like? And is there much competition? Is there much uptake? How is your life now as not just a fan, but a seller of Nix?
Yeah. I think, we've, again, the way we've been thinking about this is, again, like building a platform as a service based on a fundamentally different approach, based on Nix, has a lot of advantages, has enormous advantages. But one of the things that we also sort of took for, or a conclusion that we came to, is also that to do the CI/CD pipeline well, you should really do the CI pipeline very well. And the reason here is, when you see all these other sort of companies such as Render or Fly or whatever, there's their technique is something like, oh, if you want to try us out, we'll build your project using build packs or whatever it is, and then deploy it. But usually at some point you'll switch to GitHub Actions for running the tests and whatnot, and then you have to call into us and to let us know what it is that you built, push the binaries out, and push the Docker images or whatever it is to us. But this is kind of a narrow waist, right? Like you lose a lot of information. There's one component, GitHub Actions, say, that's doing the build, and another component that's hosting. And as we mentioned, there's a lot of information. It's really cool to have a lot of information about your infrastructure, to know exactly what's deployed, what's talking to what, how it's structured, what versions you're using, and if you have that narrow waist, not only does the user have to deal with two different things, but you lose a lot of information in that communication process. So we focused initially on CI, and we have like a decent number of companies now sort of using this as their main CI. And I would consider that very stable. The hosting part is also something that we have more and more companies adopting. But it still has some rough edges and many features missing. And then another component that we recently released is what we call Garnix modules, right? And the idea here is, the reason why Nix is part of the reason why Nix adoption is being less than stellar is because of this big steep learning curve, right? So what we do is we say, okay, here's a way of generating the base Nix configuration for various different types of projects. If you tell us, hey, I have a Rust project, and it uses this version of Cargo and Rust, and then we can generate something and create a PR in your code that captures exactly what it is that you need to do, so that you don't have to learn Nix at first, right? So that initial hump isn't there.
Yeah. And there does need to be a kind of here's your first recipe automatically written for you.
Exactly. Yeah. So then you can get to, in 3 minutes or 5 minutes, you can get to CI and deployments working, and dev shells and whatnot working without having learned Nix, right? And then if you need to change the Cargo version, it's relatively intuitive what to do, and you can learn gradually on a per need basis, rather than spending so much time and effort upfront before seeing any serious results.
Which is hopefully, I guess you're hoping, is why you won't need everyone who learns Nix to be a paid contractor first.
Exactly. Yeah. You can think of it, this last component, Garnix modules, you can kind of think of it like Ansible, I think, right? Like Ansible has this YAML syntax where if you have the Ansible recipes, I forget what they're called, you can expose a way of calling those arguments via YAML. So for most users, you can just learn how to use the YAML component of Ansible. But for users who are more familiar with Ruby and the Ansible internals, they can write these recipes, right? And so it's, and maybe at some point you sort of migrate slowly from being one type of user to another, but you're maybe amortizing that cost over the lifetime of your interaction, your usage of Ansible or of Garnix modules.
Yeah. I've never quite been, I see the logic of that. I've never quite been fond of that approach, because it means that as you become more advanced a user, there's inevitably going to be that point where you have to switch languages.
Yes.
And presumably you're avoiding that.
We'll still see, right? I think to some extent, part of what we think is like, we have to gather a lot of experience from various different users to see. It's similar actually with build packs, right? Like Heroku and I think Render as well use the same technique, which is like, you don't have to learn exactly what script is being run in order to build your project and deploy your project. You can just be largely ignorant of that, or have a tiny bit of configuration. But if it gets more complex, you're going to have to dip into those build packs, right?
Yes, but is your configuration still in Nix the language?
Yes, it is.
So there won't come a time where I need to switch language to actually use all the features.
Right, that's right. Yeah, sort of poking holes, or sort of making that transition be nice is something that like involves careful design. There's no sort of let's say that you want to override a particular version of a dependency. Maybe you have a field that does that easily, or maybe this is the time where you have to learn about fetchget or built-in fetchget or something like this, right? Like you have to decide very carefully when that happens and how it is that the user experiences that transition and how they learn about it and whatnot. And I think it's just a lot like designing a library or a programming language. It's just something that the nitty-gritty details have to be considered and done with love, right?
Yeah, and it's one of those design decisions that will eventually shape and limit the size of your user base, right?
Right. Yeah.
Are you just going to appeal to Nix experts, or are you going to try and take it to the next level where anyone can use it?
Yeah, exactly. And we hope that the answer is the latter, right? I think that's our ambition.
Yeah, absolutely. So I want to go back and pick you up on 3 features you said of using Nix for deployment, because I think this is worth you unpacking. Atomic update, like atomic deployments.
Yeah.
Why does Nix enable that? Because that sounds like a useful thing to move everything to the new version all at once.
Yeah. So atomic deployments are something that you can see in 2 ways, right? Like one question is the zero downtime question, right? Like, and this is something that's familiar to everyone. As soon as you have, something that's a little bit more than your personal website, you probably worry about the amount of downtime that you have, if any, when you upgrade the version of your OS, of your dependencies, or of your application, right?
Yeah.
Do you stop that application and start a new version? Do you have a gradual rollout, as with Kubernetes? And what we do, I think, the what I think is exciting that we do is we extend the idea of Nix to the cloud by using these hash-based names. We use them as domain names for your web service. And it's a bit of a crazy idea. But when you deploy a web, I mentioned that when you build a version of your package, it gets a hash name that uniquely identifies it, right? And if anything has that name, it's the same thing. Now, when you have a recipe for how to build an entire OS, you can also hash that and all of its inputs, and that it also gives you a name that uniquely identifies that behavior. Modulo, state, which we can talk about later. The volumes that you have attached and whatnot.
I think I see where you're going with this. So you would be able to build the new version entirely, get it up and running under a new domain name hash, and then your atomic update is switch the load balancer.
Exactly.
Yeah. Okay.
So you switch the load balancer, and that gives you the atomic part, right?
Yeah. So then we have to talk about state, because that I can see that working perfectly until my database files also need to move over.
Yeah. So let's maybe just elucidate a little bit more of the picture so that it's clearer what the advantages are and how it works, right? So we have these hashes, and as you mentioned, we switch atomically the load balancer. But the way in which each server is talking to one another is using those hashes as well, right? So the really nice thing is when you have an upgrade, and you only change one server that isn't talking to any other servers but is receiving requests from them. Then what happens is, now in theory, all the servers that are talking to it also change because they're talking to a new version, right? And so their behavior is different, right? Like in the same way that if I have a function foo and it calls a function bar and bar changes, then in some sense the behavior of foo also changed. So all of those get new hashes as well, and they all get deployed. But if it's the other way around, where you have a server that isn't being queried but is talking to various different servers, you just have to deploy that new version. And it can talk to all the old infrastructure.
Yes, so when I deploy my new version, you can say for definite you haven't changed the version of Postgres. That doesn't get a new hash, so we just the web servers just keep talking to the same old database.
Exactly. So this is a minimal upgrade, right? You spin up only the things that really changed, but it's also atomic, both in the sense of zero downtime, but just as importantly and even more excitingly, I think, the version upgrades happen atomically. You're never going to be talking. Your new version of your application is never going to be talking to an old version of your new version of the front end is never going to be talking to an old version of the back end, right? Or of server 1 versus server 2. And so you never have to worry. One thing that occupies developers a lot and is really annoying to think about is always maintain backwards compatibility in all your APIs, because nothing is ever atomic, right? Like you're always going to have different version mismatches as you upgrade and roll out things. Whereas here they're not. They're atomic. Everything's atomic. So you really can look at your code as a point in time thing, right? You don't have to worry about what it looked like yesterday before you made this change. You can develop in a very clean way. So that's another big advantage of this hash-based.
Presumably, this also makes it easy if I do want to maintain two different versions. Like if I've promised to keep the old JSON API running for that client.
Yeah. The one technique that we haven't implemented yet, but we're excited about is, leaving versions on for external users so that they also don't have to worry about this, right? Like if they use this hash domains, you can just keep track of. You can keep upgrading without backward compatibility concerns, and then just keep track in the load balancer level of how many requests are coming in from the external world for those old versions, and it, maybe you have a threshold that says, like if there's fewer than one request a month, then then it's safe to spin this down.
Yeah, unless that request is coming from our biggest client, in which case we got to negotiate with them. Bet that happens. I bet you.
Right. Or alternatively, like there are even weirder ways of thinking, right? Which is like a kind of you can develop as A/B testing sort of, right? Like you can do deployments and then just see what versions people like the most, right? Like maybe maybe you have a branch where you're doing some work and you just deploy that, and it lives as a fork or as a separate branch for a long time.
We are getting into the world where this one language which describes my dependencies and my language dependencies and my out-of-language dependencies and my deployment infrastructure also describes my A/B testing.
Yeah.
And my feature flags.
Yeah. Exactly. Yeah. That's exactly right.
And not having separate languages and separate configuration files for all those things sounds like where we should be.
Yeah. I agree.
So this suggests that most of your future is going to be figuring out comfortable ways to describe this and then building out all those tools that introspect on these descriptions and surface things like here's a CVE you've got to worry about.
Yeah, absolutely. Yeah.
You must be hiring UI people. Or you will be if you're not currently.
So far we've, because the majority of our customers until 2 weeks ago, all of our customers were Nix users. I think they're already kind of familiar with these ways of thinking, and so it's been relatively easy. But now, as we sort of start to expand this, it really does involve thinking very hard about how to present this in a way that makes sense, right? That feels intuitive.
Yeah. Okay, so I'm probably not a great barometer of this because I'm an existing Nix user who was forced/paid into it, but actually became a convert. But there are probably people listening to this who are tempted to try Nix, and perhaps they can become a small flood of testbed users for you. So the question is, how do you get started? Where would you recommend someone who's not being paid for it to get started with Nix?
Yeah, so this is a bit self-serving, but I think, our new modules project, garnix.io/modules, can help, with Rust or Haskell or NPM projects, for instance, can get you a lot of the way, or the entire way into having, hopefully the entire way into having a project that compiles and builds with Nix and CI. And obviously, the way I would like for this to work is that this becomes independent of Garnix altogether. In some sense, I think vendor lock-in is a terrible thing, and so to some extent, I hope that people consider this even if they don't want to use Garnix for anything else, for CI, or that they generate this file and then go off and build their project in themselves in a different CI system and deploy it however they want. But I think that that's a very good way of sort of, seeing that initial experience, right? Like seeing, okay, this really works, and I can sort of understand the package infrastructure, and I can look at the syntax and then see how it reflects facts about my project that I specified, and understand a little bit about Nix, and get a lot of the benefits, right? Like already get a dev shell that works for my project. CI.
Which languages do you support? Because I've tried this with one of my Rust projects, and I thought, okay, if I'm a Rust user, this is pretty straightforward.
Yeah, yeah.
But
Right
presumably
now,
you have to write recipes for lots of different languages to make this universal.
yeah, it's right now it's only Node.js projects, Haskell projects, Rust projects, and then also Postgres databases and Linux users as configuration uh, for your web service if you choose to deploy web service as well. Um, but we want to expand that a lot, and I think if there are people out there who are really excited about trying this out and want to reach out and say like, this is the project that I want, I think for us it's very helpful to have that sort of tight feedback loop so that we can see, okay, like what is working, what isn't working for you. So do feel free to reach out if these aren't if what you're looking for isn't supported yet. But so far it's those three tech stacks, right?
Okay, I'm quite surprised to hear Python isn't one of your early adopting languages.
Yeah, I think Python is the natural next one. And yeah,
that raises a question I haven't asked, but I'm just going to dip into it quickly. What language are you building this in? Presumably it's one of those three you've already mentioned. You're either doing this in Node, Haskell, or Rust. Tell me. I reckon I can make a guess, but tell me.
Actually, the full answer is all three. Our front end is, a Node.js project, and we have some DNS servers and load balancers and whatnot that are in Rust, some small projects that are in Rust, but the majority of the code base is in Haskell.
Right. So what you actually need is a dependency that's built in Python for that script to get to production quality. Yeah,
exactly. And this is why I say that having contact with someone who is so useful at this stage, because so far it's been very easy because we say, okay, like let's try this out we're familiar with these stacks. Let's try it out for our own projects. Let's try it out for a couple of friends' projects and whatnot. But as we move towards, Ruby, for instance, the language that I don't have very much familiarity with, I think it's good to be talking to people who do.
Yeah. It's also, I'm not sure you'll ever get there, but Nix is one of the few languages that at least makes the environment of Perl feel sane, because someone's had to go through all the pain of writing Nix recipes to build Perl reliably.
That makes Perl less of a pain, you say?
Yeah.
Yeah.
I don't think you'll be deploying Perl anytime soon, but you could.
But I also think, Zig, for instance, or Gleam, or things like, these new languages that could also be exciting, right? Like,
yeah, and those are ones that maybe haven't got a fully realized infrastructure story yet.
Yeah, exactly.
Yeah. It's difficult to know whether you should go after the biggest players or the most hungry for new services players.
Right. Yeah, and it's also, to some extent, not only are these technologies newer and therefore maybe have less support, but also the projects in these languages are themselves newer. So it's more likely that you haven't yet solved, or that a big proportion of those projects haven't yet solved the question of how you're going to get this deployed, right? Whereas if you're running a Java project, those are mostly, I would think, like proportionally more legacy projects. It might be more objectively, but the majority of them have already solved these questions in one way or another.
Yeah. If you're spending serious money on Java, you probably already know what your deployment stack is.
Yeah.
Well, in that case, it sounds like you've got a lot of work to do and a lot of market research to do.
Yes, absolutely.
So I should probably leave you to go and do it, while hopefully a couple of the listeners give you some more data to play with. And that more data will force you to do a data mining project in Python, and we complete the loop.
Perfect.
And on that note, Julian, thank you very much for joining me.
Thank you as well. It was a pleasure.
Cheers. Thank you, Julian. So, as always, take a look in the show notes for links. I've put a link to the Nix Getting Started guide in there. If you're using one of the languages that Julian mentioned, Garnix is actually looking to be a pretty good way to get started with Nix quickly. So you might want to try there. Before we go, I'm going to leave you with the single most terrifying thing that Nix has taught me over the years. So Nix is a tree of dependencies, and it goes all the way down to the kernel, as we've discussed. And when you're building something, you can look at the logs and see that what you're building depends on these things, and those things depend on these things, and so on, all the way down. You get the whole dependency tree staring back at you. And I promise you, no matter what stack you're building, no matter what language you're using, somewhere in your dependency tree, you're depending on Perl. Absolutely promise you. So, huge respect to Larry Wall for creating one of the foundation stones of everything we use. But also, you might want to take 2 Valium before bedtime. Before you go and get that prescription filled, if you've enjoyed this episode, please take a moment to like it, rate it, share it with a friend. Make sure you're subscribed for the next episode. And if you're really enjoying the episodes, consider going to Patreon and supporting us. But for now, I've been your host, Chris Jenkins. This has been Developer Voices with Julian Arni. Thanks for listening.